Yes. So we were discussing the chapter haloalkanes and haloarenes, right? So in the previous session, we have seen the MCQs as well as the fill in the blanks. Okay, so as you know, this chapter is for 9 marks. And from this particular chapter, you'll be getting 1 mark, 2 questions, 2 mark, 1 question, and 5 mark, 1 question. Okay, so this 5 mark question is not asked directly for 5 marks. It will be further divided into 3 plus 2 mark. Okay, so direct questions in chemistry for 5 marks are not asked. Okay, either it will be 3 plus 2 or sometimes in rare cases 4 plus 1. Fine. So moving further, so these were the questions which we have already discussed. So today we are going to see, and we have seen some 2 marks questions also, right? Some of the name reaction, important name reactions. So we have explained what is Darzin's reaction with example, then explain Finkelstein reaction with an example, then Scott's reaction, Sandmeier's reaction, Wood's reaction, fatigue reaction. Then we have seen Wood fatigue reaction. Then we have seen Friedel-Crafts alkylation, reaction of chlorobenzene. Then we have seen Friedel-Crafts acylation reaction of chlorobenzene. Then we have seen the terms what is chirality, what is chiral carbon, what is racemization, what is enantiomers. Okay. Then we have also discussed what is a racemic mixture. Give an example. Okay. So today we are going to discuss the remaining questions. So we are going to start with the 12th question. I think we have stopped there, right? So we are going to start with the 12th question. So what does ethyl bromide react with? How does ethyl bromide reacts with? A, alcoholic KCN and B, alcoholic AgCN. Yes, how does ethyl bromide reacts, students? So each reaction, 1 mark. Okay, so for the each reaction, you'll be getting 1 mark. Fine. So how you are going to write this particular question? How you are going to answer for this? Alcoholic KCN and alcoholic AgCN. How is this? Yes, what will be the products? Try answering this. What will be the product, students? Okay, I'll write the structures. Firstly, I'll write the structures of ethyl bromide. So ethyl bromide is what? CH3, CH2, Br. So ethyl bromide, when it reacts with alcoholic KCN, okay, that is potassium cyanide. What will be the product obtained? Yes, what will be the product obtained? It will be CH3, CH2, CN plus KBr. Yes, is it right? Yes, is it right? Fine. So this is the first. Okay, how when ethyl bromide reacts with your alcoholic KOH. Okay, when ethyl bromide reacts with alcoholic KCN, this is the product which is obtained. Secondly, when ethyl bromide, that is CH3, CH2Br, reacts with alcoholic AgCN. Okay, alcoholic AgCN. Yes, what will be the product? Yes, what will be the product? So this is a cyanide. Okay, you get a cyanide. Okay, you get what? Ethyl cyanide. What is the product obtained? Ethyl cyanide. Here, what will get? CH3, CH2, NC plus AgBr. So what it is? It is ethyl isocyanide. Okay, NC bond. So whenever you are attacking, okay, whenever you are reacting it with AgCN, okay, AgCN, it is a covalent compound. Fine. So that time you will get what? CH3, CH2, NC. Okay, so that is what you are going to get a isocyanide compound, NC. Okay, nitrogen will be attaching to your carbon. Okay, nitrogen. So the carbon will get attached to nitrogen. So it is ethyl isocyanate. So these are the products which are obtained when your ethyl bromide reacts with alcoholic KCN. Okay, you get a cyanide, and when ethyl bromide reacts with alcoholic AgCN, you get isocyanate. Okay, fine. Moving further. So these were some of the 2 marks question. Okay. So now we are going to discuss 3 marks question. So very important 3 marks question. These are to be so without okay. So you should not leave these 3 questions. Okay. These are the must questions which you need to study. So first one is aryl halides are less reactive towards nucleophilic substitution compared to alkyl halide. Give 2 reasons. Okay. So if they have asked for 2 reasons, it will be asked for 2 marks. Yes. Okay. So when the question is asked for two, okay. So if the question is asked like for 2 reasons, what they've asked here, give 2 reasons. So if it is asked for 2 reasons, you will get 2 marks. Okay. So if you give 3 reasons, so if you give 3 reasons, if the question is asked, okay, aryl halides are less reactive towards nucleophilic substitution compared to alkyl halide, give, okay, if the question is asked for 3 marks, you have to give 3 reasons. Okay, depending upon the type of question asked. So if they have mentioned 3 reasons, the question will be for 3 marks. So like that, you have to write it for 3 marks. So here they have asked it for 3 marks. So what is the answer? What are the points to be covered? So first point is what? The CX bond. Okay, the CX bond will acquire a partial double bond character. CX bond will acquire partial double bond character due to resonance. Okay, this is the first point. So what is the first point? The CX bond acquires partial double bond character due to resonance. So this is the first point. Second point is what? Carbon. So the carbon which is there in the haloarine. So this is the haloarine, right? So the carbon which is attached to the haloarine. So this carbon, it is sp2 hybridized. So the carbon which is there in the haloarine is sp2 hybridized, and it has more S character. It has what? It has more S character and hence more electronegative. Okay, it will be more electronegative. So it can hold the electron pair of CX bond more tightly. So what will happen? It will hold the CX bond more tightly. So this is the second point. And what is the third reason? You can write instability of phenyl cation. Okay, instability of phenyl cation. So this is the third reason. Then the fourth reason is what? Electron-rich benzene ring will repel electron-rich nucleophile. Okay. Electron-rich benzene ring will repel the electron-rich nucleophile. So these are the 4 reasons. So out of this 4 reasons, based upon the type of question, if the question is asked for 2 marks, write 2 reasons. If the question is asked for 3 marks, write 3 reasons. Okay. If you write one additional reason also, so if any one of the above reason is wrong, okay, so your extra whatever you have written, so that will be that will be counted then. So if you know all the reasons, so please write all the reasons. Okay, you can get good marks there. Fine. So this is the question. So this is important question asked. Okay, very frequently. So if you see the previous year's question paper, so these questions are they are asked compulsorily. Okay. So aryl halides, why they are less reactive towards the nucleophilic substitution reaction compared to alkyl halide. Then the second question, explain SN1 mechanism with an example. Yes, explain SN1 mechanism with a example. What is SN1 mechanism? Yes, what is SN1 mechanism? SN1 mechanism is what? substitution, nucleophilic, unimolecular. Okay, substitution, nucleophilic, unimolecular. So this particular mechanism, that is SN1 mechanism, will proceed by how many steps? It will proceed by 2 steps. Okay, it will proceed by 2 steps. Firstly, what you need to write? Firstly, you need to write the general reaction. You need to write the general reaction. So I'll write the general reaction. So C, CH3, C, CH3, CH3, and Br. What is this? It is a tertiary butyl bromide. Okay, tertiary butyl bromide. Then tertiary butyl bromide plus a nucleophile OH. Okay, in the presence of OH will give you what? CH3, C, CH3, CH3, OH. Okay, plus NaBr. You can write this. Okay, so this is our general reaction. So write the general reaction first. Okay, then you have to write. So you know that SN1 reaction proceeds with 2-step mechanism. It proceeds with what? It proceeds with 2-step reaction. So what are the 2 steps? I'll write it here. Okay, so I'll write the 2 steps here now. So what are the 2 steps? So step 1. Okay, step 1 is what? Formation of carbocation. Okay, formation of carbocation. Formation of carbocation. Yes. So how is the formation of carbocation? So CH3, 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 Br. Okay. So this is a slow step. So first step is a slow step wherein this breaking of this CBr bond takes place. Okay. This is a carbon halide bond takes place heterolytically. So the breaking of the bond, that is CX bond, takes place heterolytically. Okay, so slow step where the tertiary butyl bromide will undergo ionization slowly. Okay, and as this is a slow step, as this bond breaks, okay, and there will be formation of tertiary butyl carbocation. Okay, so this is a tertiary butyl carbocation is formed plus Br minus. Okay, so what is formed here? Tertiary. So write the names here. Tertiary butyl bromide. This is tertiary butyl carbocation. Okay, fine. So this is our first step. Now, moving further, which is the second step? So second step is a slow step. So I'll write the second step here. Second step is a fast step. Okay. So what will happen in second step? So second step is a fast step. Okay. So what will happen here? The nucleophile, the incoming nucleophile. So this, whatever the carbocation form here, so that you have to write here. So CCH3, CH3, okay, just a second. So CH3, CH3 and carbocation. So what will happen? The nucleophile. So OH minus is our nucleophile. So the nucleophile will attack the carbocation. Okay, the nucleophile will attack the carbocation at fast rate and the product butyl alcohol is formed. Tertiary butyl alcohol is formed. So these 3 reactions. So for general reaction, so tertiary butyl alcohol. Okay. So for your 1 mark, if you write this proper reaction, general reaction. So for general reaction, you will get 1 mark. So this general reaction should be mentioned. Okay. Then step 1, write the reaction. Okay. Carbocation formation and write 1 small sentence. Okay. How this step is formed. That is tertiary butyl bromide. It undergoes slow ionization to give you tertiary butyl carbocation. Okay. So this first step you have to write and give a small explanation. Then step 2 is a fast step where the attack of the nucleophile takes place at the tertiary tertiary carbocation. Okay. And your product tertiary butyl alcohol is formed. So these so these 3 steps and what you have to write is the small explanation. Okay. So this will fetch you 3 marks. Is it clear? Yes, is it clear? Is it clear, students? Okay, fine. Fine. So this is a compulsory question. So please practice this as much as possible. Okay. So as you know, in organic chemistry, you cannot by heart it. Okay. You cannot by heart it. You cannot just read it. You cannot just see through your eyes and understand the things. You need to practice. Okay. This reaction should be practiced. So as much time you if you practice, so that much it will be good for you. Okay. So you need to practice. So if you practice, if you keep on writing it, then only these reactions will be perfect. Okay. So without undergoing any mistake, you can write it properly. So these three steps. So one general reaction and two steps of that. Okay. With small explanation will fetch you 3 marks. Fine. So the next question is explain SN2 mechanism with an example. SN2 mechanism with an example. Fine. So what is SN2 mechanism? So SN2 mechanism is what? Substitution, nucleophilic, bimolecular. Okay. Substitution, nucleophilic, bimolecular. So I'm writing here shortcut. Please do not write shortcut. Okay. So substitution, nucleophilic, bimolecular reaction mechanism. Okay. So this is SN2. So SN2 mechanism is, it proceeds with one step mechanism. Okay. It proceeds by one step. Okay. So what is the one step? So first we'll write the general reaction. So first we are supposed to write the general reaction. So I'll just take this down. So I'll write it down. Okay. See here, I'll write it here. So SN2 mechanism. Okay. So what is SN2 mechanism? So methyl. So I take a primary haloalkane. Okay, I'm taking a primary alkyl halide. So that is methyl chloride. So methyl chloride is reacted with the aqueous KOH, giving you methyl alcohol plus KCl. So we have to write the names. So what are the names? Methyl chloride. Then this is methyl alcohol. The product is methyl alcohol. Fine. So this is the general reaction. General reaction of this particular mechanism. Now, so what you have to write? When methyl fluoride is heated with aqueous KOH, methyl alcohol is formed. Okay. Now, what is the mechanism? What is the mechanism? As we said, this mechanism is one-step mechanism. Okay, this is a one-step mechanism. So here, your methyl uh, chloride. Okay, your methyl chloride. So what will happen to this methyl chloride? The attack of the nucleophile takes place from behind the carbon. So attack of the nucleophile takes place from behind the carbon. Okay, so SN2 mechanism, it involves one step. Okay, the nucleophile OH minus, it attacks the it attacks from the backside. Okay, it attacks the carbon, electron deficient carbon from the backside, or it is said as rear side. Okay, to form it forms a transition state. It undergoes a transition state which is unstable. So what is a transition state? So this attack, okay, and this is hydrogen, your other two hydrogen, and your Cl bond. So it undergoes this transition state. Okay, and this transition state is unstable state. Why? Why it is unstable? Yes, why it is unstable? Because the carbon is having here 5 bonds. The carbon is having here 5 bonds. So 1, 2, 3, 4, 5. Right. So when carbon has 5 bonds, it is unstable. Okay, so it is undergoing a transition state. So in this transition state, what is happening? This bond, I'll just show you. This bond, that is HOC bond is forming. Okay, there is a making of HOCO bond and there is a breaking of CCl bond. So this bond is getting, broken. Okay. So in the transition state, HOC bond is partially formed and CCl bond is partially broken. Okay. So further what is happening? The CCl bond, okay, it will break completely. Okay. It will break completely and your product HOC H H H plus Cl minus. So this is the product which is formed. So what is the name of the product? It is methyl alcohol. Understood? Is it clear? So these things you have to mention. So what is important here? General reaction, then this mechanism and explanation. So explanation should be must. So what should be the explanation? The nucleophile OH minus is attacking from the rear side of the carbon, electron deficient carbon. Okay. And it is undergoing a transition state where HOC bond is forming and CCl bond is breaking. Okay. So partial making of HOCO bond and CCl bond is partially broken. So further, the CCl bond is broken and it forms the product methyl alcohol. So like this, you have to explain. So explanation is very important. Okay, 1 mark for explanation, 1 mark for this general reaction, 1 mark for the mechanism. Is it clear, students? Is it clear? Yes, everybody, is it clear? Okay, fine. So these were the things, okay, which are important in haloalkanes and haloarenes. Okay, so in haloalkanes and haloarenes, so okay, all the name reactions are very important. Okay, all the name reactions are very important. So what you have to do, you have to study all the name reactions, wherein you have to study the name reactions with example. Okay, so general reaction, example, and explanation for the name reaction. So you have to do perfect with this all name reaction. And these name reactions, you cannot bahart it. So what you have to do, you have to practice as much as possible. Okay. So as much as possible, if you practice the things, okay, then only you can okay, you can write them in the exams. Okay, if you bahart, you cannot reproduce them in the exams. So you need to practice as much as time. Okay, fine. So is it clear? Is the topic haloalkanes and haloarenes is clear? So these are the things which are to be covered in this particular chapter, and I have dealt with all the things. So any doubts in this chapter? Because I'm going to move to the next chapter. Any doubts? Okay. All the things are clear. Yes, will you be able to write the things, whatever have been told? So as I have mentioned you earlier, please write the important things. Okay. Please practice all the, so organic chemistry, all the, okay, the previous chapters, that is electrochemistry of solution chapter. So you need to practice the sums. Okay. You need to practice. So without practice, you cannot do anything. So in chemistry, you have to write as much as possible. So all the name reactions, all the things should be practiced. Okay, fine. So if there are no doubts, so I'll be switching to the next chapter. Just a second.